Hey Mark,
Good day. How are you?
how are you?
I am well. It's
I'm
6
glad.
a.m. I've been up for 3 hours.
3 hours, how so?
I don't know. I get up super early. I went spent a week in Jamaica over the holidays, and it's on the East Coast, so it's 3 hours ahead of us
Ah,
here. And I thought, oh, for once I'll be like a normal person. But no, by day three, I get up at 5 a.m. Jamaica time, which is 2 a.m. Seattle time. Anyway,
all
I'm
right.
just waiting for more people to join this call.
Yeah, no worries. Here they are.
So yeah, I'm just like while I'm waiting for people to join, I'm like trying to update wording of this document. I'm gonna um I'll put you as an attendee. It's been a lot spotty here with attendance in the last um few weeks, but
Thank you.
we're still making actually quite a bit of progress.
Hey Mark, good
Oh,
morning. Good morning, everyone.
Mandel, how are you? Good to see you.
Good. Thank you.
Yeah.
Likewise.
So, um, okay. Well, because I'm not busy at all, I'm just going to. Um, how are things in Hushmesh land?
Busy.
Good.
As I said, the NATO stuff is interesting. So
Mm,
it's picking up, and it's very from a CCC perspective. I haven't told them yet that they should join the CCC, but it is interesting to see how even in those spheres, NATO, you would think that's the place where they would need technology like confidential computing,
yeah.
and there's very, very little awareness of its existence and of the capabilities that it enables. So it
Well,
is
that
very
tells you how
interesting.
much disconnect there is in government. Because I attended a workshop a couple of years back hosted by DARPA. I don't know if you remember it or not, but DARPA reached out to the to people in the confidential computing land, and they wanted to see if they could use T's as a skiff.
Oh, wonderful.
I don't think you can, but
Not yet, not yet, but I think it's, the next generation maybe, and at
I
some
think
point
they're
we may be able to.
confusing a hardware-based trust execution environment with, humans. Like human, you have to actually put in a physical room,
Right, right.
and I think we should not be anthropomorphizing our computers.
No, for sure. And I think, I mean, there's always pushback, right? That a TE is not perfect. You don't have perfect security. There's attack vectors and all that good stuff. But given that all these agencies and all these institutions have very, very strong physical security to begin with,
Yeah,
adding TEs basically doesn't hurt. And
yeah.
then as the technology matures and you have better physical security at the chip level, then you'll be able to relax your physical security for the whole network. And so that's the journey that they need to do, and the conversations are just
Well,
fascinating.
yeah. I think this is the same trifecta argument. Like yeah, we bother protecting data at rest. Why not in use? It's not that different.
That's right.
All right. So, okay, we're gonna start because it's 5 minutes past the hour. And so, quick updates. So I met last week with a fellow named Joe Salloway. Uh, he's in Seattle. He is one of the principals of the Whimsy Working Group at the IETF. And we had a really good discussion with him. And the long and short of it is he seems to have agreed that the Whimsy architecture needs to be spliced into two parts. Now, there is a subtle difference between how we are treating uh, the two parts in this document. So we are separating provisioning phase from the acquisition phase. So provisioning phase has everything to do with what the control plane does, and the acquisition phase has to do with what the workload does. So that's just to sort of page all the information back into your memory. You already know this. But for Whimsy, the line is going to be drawn kind of further to the right. There is going to be all the activities involved in making sure that the workload has a credential in its possession. And then on the other side of the line is all the activities the workload does with the credential. So both the format of the credential and all the use cases, including how do you traverse reverse proxies, how do you communicate between workloads, like all that stuff. Uh, that effectively is Whimsy should separate the two such that everything to the left of the line could be made flexible, right? So today, the Whimsy reference architecture has this wart that talks about how there is an agent, because they effectively try to codify what the Spire architecture does. But that's sort of one way of skinning that cat. But I basically pointed out to him that there are at least three different mechanisms for how the workload comes into possession of a credential, and there could be others. And this is, by the way, where I want to understand that HashMesh has its own say in how this is done. But the three mechanisms are the control plane gives the credential to the workload in plain text, and that's what happens today. So both credential and the key. The second one is what we're documenting here, where the control plane somehow manages to give the workload a plain text credential and a wrapped key. And then the third one is the one that we talked about in the Montreal ATF, and that's where the workload generates its own key and certifies it. And that we're not tackling that one yet. But there could be others that, whatever they are, those become the different credential acquisition profiles. So we agreed that we're going to go in that direction, and they're going to put some words in an upcoming ATF document to that effect. And I will follow up with Joe to, see how he progresses on that. But that, I believe, is a kind of a procedural slash architectural win for our effort here, because it's really, allows us to then play freely in that domain and have the mechanisms that we need for what we're doing. Okay, so with that, I want to spend a little bit of time reviewing some of the words and comments that are in this document right now. So let me first do this. I'm going to put the link to the document in the chat. So this is the profile. Here's the link, so you can click on that. And let's just go first off over the stuff in green. So these are the changes that I put in suggestion mode since last week. And what we did, we basically said, we really need to name these keys, give them like acronyms, talk about them specifically about what each does, and then the subsequent diagrams, if you like scroll down and look at these pictures, they now specifically say here's a CW gain, here's a CS gain, here's like all of that. So yeah. So anyway, so this is what I would like to do. So we can basically go through this, and if we like the text, I will accept it, and that becomes part of the document. And there are of course some questions. What I want to do is I want to put this first. And then this becomes heading one.
Looks good to me.
Okay. Well, so I in for one and for three, I talk about generation, where the thing is generated. For two, I kind of put it to do. Do we say something about where it is generated? And the reason I left it out is because this is where I want to make sure that we leave a branch or fork for hash mesh. So
Well,
note,
actually, the in our world, um, the the verifier. So in our world, all the other actors, right? The identity provider, the key, the keys, the what is it? The key, how do you call it? The key store or the key
well, the
management
key
thing?
store is this like a, yeah, some kind of
In our
HSM.
world, everything, all those actors collapse in a single one, which is the verifier, and then we have this, verifier or verifiers network. And
Hmm.
so the asymmetric key, the credential signing key, or any other key that the workload is going to need for over the life of its existence, and that needs to be shared across the individual instances of the workload that may run on different servers, all of that is generated by the workload itself. That's how we know that the workload is the only one to actually have access to those keys. And that's
Yeah.
what guarantees exclusive agency. That's what enables provenance, because you know that it could only have come from that. The wrapping key comes from the verifier itself, passed to the workload, and to the first workload that generated its own keys, right? So that that workload, that the first work instance that could generate the keys can then wrap them, store them, so that its siblings, the other workloads that are instances of the workload that are, scaling horizontally, can then grab the encrypted bundle of keys and then use the symmetric key that they get from the verifier after passing remote attestation.
So
Right. So
what I'm hearing,
that's what we guarantee, that only attested instances of a workload have access to the keys that they have generated for themselves.
yeah.
So that the parent, the verifier, never has access to them. And if the verifier is run in a separate administrative domain, that there's a clean two-key separation mechanism, that the parent, although it has access to the wrapping key, doesn't have access to the wrapped keys of the workload. And now you have a separation of concerns.
Okay. So, but the question I then have is that seems to be a separate profile from the one we're documenting here. It's like it's sufficiently distinct that I can't just make, a small tweak here and there. Because if you look through the um, diagrams and sort of the workflow that's proposed here, it is not done in your world. It is very specifically this is where this key is generated, this is where that key is generated, and in this case, the each workload doesn't have.
So hold on. It is, yes, what I'm describing to you here is the optimal security posture for an agentic type workload that needs to have its independent existence of everything else. But we also support other legacy workloads that may not run in a TEE and that may receive a key bundle from its verifier. The verifier, in this case, acting as the multiple, functions, right, that you have there, the key
Yes.
management, et cetera, et cetera. So we could, and we actually do have the ability to deploy exactly what you're showing there, where a workload can get is a signing key from its verifier. In fact, it's very much the mode that you would want to have if you don't have assurance that your workload has access to a true random number generator, for instance. Most workloads that would run on conventional hardware would not have a full entropy RNG, right? So you would want to have high quality keys. You actually want those signing keys to come from the verifier. Because guess what? If you trust the verifier, you might as well trust the keys that come from it, right?
Okay. So again,
So we support this mode too. I think this mode is
you
better.
support it is different from what I'm saying, right? So we can document this, and then you can basically say, okay, we'll support this. What I am saying, however, is that you also have another mechanism of the provisioning part that is different from this one. And as a result, your acquisition in your pure mode, whatever you want to call
Yeah.
that, is also different. So in that case, what I'm really uh, going for is, remember how I basically said there are at least three, maybe more of these
Yeah.
mechanisms? Maybe, or and I want to call them profiles, like, or
Yep.
whatever. We'll find out some sort of name for them. But you will probably need a hash mesh profile for Whimsy, which you will
Yep.
support. Will support the hash mesh profile and will support the TWA profile or whatever, wherever we end up calling this thing.
Yeah. I think we should present them as a spectrum, right? And you're correct to point to the fact that it depends on where the keys are generated, because it is at the end of the day, right? In a world where everything is cryptographically verified, it ends up being where the keys have been. Which actor has had access to the keys over the entire life cycle of the keys themselves.
Yeah,
So it really is about decentralized key management. So what really matters, and I think what differentiates the profiles, is not just the different actors and how, if they are different trust bases, or if they are collapsed into one single trusted actor like the verifier, but it's also the where the keys are generated, and which actor has had access to those keys, because then it determines the security properties that you can get from the system.
yeah. Okay, so let's then resolve to get to a point where we can publish these profiles with ease, and have some sort of registry of them. And then we will document this one as is. This will becomes your, like, Hashmesh's legacy thing, how you deal with legacy workloads. That's great. And then what that allows me to do is basically saying, look, for purposes of this profile, at least for now, um, the CSK is generated inside the key store, just like sorry, C, yeah, CWK.
That's right.
uh, CSK, and is uniquely bound to it, so that no two CSKs can have the same CWK. I just want to mention this because this can become a security vulnerability. You get one
Yes,
wrapping key, they can go unwrap a bunch of different signing keys. That's a problem.
correct.
Okay,
CWK, yeah.
same. Sweet. Abdullah, you raised your hand. Hi.
Yeah. Hey, sorry, Mark. Well, first things first. Can you paste again the link because I was not able to open it in edit mode and I couldn't see what
Yeah,
you
yeah,
were
yeah.
working on.
Of course. Hold on.
Uh, the other thing I want to ask, and might be a silly question, but just for clarity or in my head, at least,
Yeah.
Manu, when or and Mark, when we speak about the key store, we're speaking about HSM.
An HSM
Uh,
is a kind of a key store, yes.
right. Okay. But
In our
are
Um,
world,
we?
in
we
our
are
world,
assuming that the key store has a set of capabilities which Sudar on Davis's team is prototyping. So we'll actually double check that this is in fact possible. So when we get down to the diagrams, you'll see that it's keys, like a key store is a key store, but can it actually do the thing we need it to do?
Okay.
yeah,
And then
and
if not, then we'll need to figure out how to, or shim it or do something.
Yeah, and Abdullah, in our world, the key store or the key generation and the key management thing is done across a network of TEs actually. So I don't know if TEs may not have all the physical security properties of an HSM, but for the purpose of this architecture, assuming physical security around the TEs, the TEs, a network of TEs essentially is where is how to say that is another option versus an HSM.
Okay. All right. Thanks. Thank you.
Mhm. Okay. So, let's just continue going through this. So, on the proposal, the workload obtains workload credential and the encrypted CS and the CSK from the control plane. Okay. Um, all right. So, we already talked about, let's see, I just have a comment on this from the key store. It's actually now the acquisition phase. No, I think that's already handled. So I'm going to close that. Yeah. I so okay. So the comments on this one really have to do with a bit of a struggle I'm having. Because this document now seems to be serving a couple of different purposes. Uh, One is to say there are multiple ways to do a thing, and then specifying a way of doing a thing. So um, at some point in time, I think there has to be wording outside of this document, basically saying, look, there are multiple profiles. This is what they have in common. And then this document just focuses on one profile, one way of doing things, right? And this is where um, yeah, that's why I'm saying, is this about operations, fitness for purpose, all this stuff? It's really, if you don't like how this one doesn't fit your purpose, maybe you can try another profile, and then we'll need to figure out how a workload, you know, knows upon waking up which game it's playing.
So agreeing. I'm just wondering if wherever we are gonna, this is gonna be kind of like published, shouldn't that be part of like maybe to your point, the profile descriptions with maybe anti-goals document?
Well, uh, I think the ultimate goal of this document is to define one way of getting something done. And if there are other variants, then it should probably, unless they're very, very minor, we should have parallel documents that describe other ways, right? And then it should be the whimsy architecture that says, well, here are different, like, you can pick a profile for how you're gonna get the credential to the workload, and then a separate set of documents about usage. This is how I said it earlier. So, yeah.
I mean, it seems really that the only variations here are where the keys are generated, right?
And stored, yeah.
That's all there is. And so I don't see the need for multiple documents. I think we should just say it ends up being really the identity of a workload ends up being uh, and the security properties of that work that they can be obtained from whatever choice you make of the profile depends on where the keys have been generated and how they've been passed. I mean, the passing to the workload is basically, if you pass it directly, then obviously the giver, right, has the key too. If you pass it indirectly, then you can separate the concerns. If you generate them in the workload itself, then the giver never had anything. And if you separate the administrative domains of the workload and the giver, whatever we call it, then you have complete exclusive agency of that workload. And
Well,
that
I mean,
really is, I think, is the spectrum that from the beginning I told you. I think we should highlight that there is an optimal scenario in which you have cryptographic guarantees that only a specific workload had access to specific keys. And then you can relax that by just saying, well, if the workload can't create its own keys, then it gets it from another actor, ideally the verifier, that's the smallest, the least trust model. If it gets it from yet another actor, like a separate HSM or something, then it increases your trust base, but it's another possible thing. And then, yeah, if
yeah,
if if you don't have the wrapping key, that was the discussion we had a couple of weeks ago, then obviously you cannot decouple the provisioning and what was the other term?
yeah.
The
So,
acquisition.
so again, the very clear feedback we got from ITF is you want each document to be as laser focused as possible.
Okay. I
This
mean,
is where I really do think that for us to be more effective acting in that organization is a document should be a prescriptive guide to how something should be implemented. And if you want to implement something else, there should be another document for how to do that.
That's fine with me.
All right, this is where I'm
Yeah.
basically saying if if the difference between recipes is, eggs over easy, eggs sunny side up, fine, right? But if it's, like, well, you could blanch it this way, you could fry it that way, you could maybe do it this other way.
Well,
Well,
hold on.
what?
That's not what I'm saying, right? What I'm saying is, and that's my push here is precisely because I'm kind of annoyed with the ATF basically separating and keeping stuff out of scope and then not really addressing the security, considerations, and having that as a North Star. Given that we are the CCC, I think we should be the ones providing a North Star saying that we start from a place of the optimal hardware backed, verifiability and then an ability to generate keys within those environments. So that is the optimal security posture. And then as we touch the real world, then of course we need to relax that because not all workloads are in that case. And then we need to do, I really appreciate and it resonates with me, the idea of having a seamless, mechanism across, TE-based workloads and non-TE-based workloads. But we should be the North Star, basically guiding the implementation. Because if we have multiple versions of this and not really highlight that this is the preferred one, then I think we fail as the CCC. It may be good for the ATF because the ATF is very much about everybody can do whatever they want, as long as they do it, the same way
Well,
that somebody else.
see,
But
for once we put something through ATF, it's easier to get it standardized. And then
yes.
in the CCC, we could say, well, these are all the IETF modes that are out there, and this is our guide to you how to choose the one that's best for security. We
Sure, no,
could
I
do it that
understand.
way.
I understand. And I think, as a startup, we don't have the bandwidth to go and fight those fights. But
Yeah.
for JP Morgan, I definitely understand how important it is.
Very well.
But it is also, I think, as the CCC and JP Morgan at the CCC, we should really try to, push for a security posture that fully leverages the capabilities of TEs.
Yeah. So I will challenge now at this point all of this right up. I know you added this menu, but this is exactly where, like, when you say, for instance, a wrapping key can be thought of as a ceiling key shared across all instances the workload. That is sort of outside the scope of what we're doing here. In fact, if a
Hey,
wrapping key can,
I put those paragraphs because you asked me to put something there about that
yeah,
specific topic. So, take it out. I know you have a specific purpose with this document. I'm not married to it, and that's totally fine with me.
okay, then we'll probably have to just. It's just the thing. I'm very worried about putting any content in here that will, you know, detract from its focus. Do you want to maybe take a snapshot of it and, like, for somewhere so we don't lose the content?
No, it's okay.
Okay. All right.
We have
So,
we have the context in our implementation, so we're good.
yeah. Okay. So, okay, now let's just quickly review what we're doing here and see if there are any things that need to be corrected. Specifically, the binding between the CWK and the CSK needs to be very, very much clear that you can't just go, use the same wrapping key for multiple CSKs. It's the kind of trouble I don't want. So, all right. So this is, again, our provisioning phase. And the provisioning phase, the control plane, right? So that's the workload owner / control plane. Creates the workload identity. And actually, perhaps, I just want to leave this kind of like, is workload the owner the same as a control plane, or are they somehow different? Like, which term should we use? I just want to leave it out there, again, for precision. Because I use control plane elsewhere, and sometimes your workload owner. And again, if they're different, then we should explain the difference between them and the difference like the different roles they play.
Yeah, but that again will come back to, I don't know how you handle those things. It seems to me you have to make a choice for the documents, and it seems like you're approaching it from the control plane and the workload owner are one and the same. Um, but indeed, if they're different, then you have very different security properties, right? Because the control plane, in our case, the verifier is operated by another organization. It will provision the CWK and or the signing key, the CSK.
Yeah.
And then the workload owner now can actually control the deployment pipeline and the code that's being deployed, but doesn't have access to the keys of that workload. That gives you security properties that you couldn't get if they're both the same. So it goes back to, again, what it is, if you're trying to implement and I think that's the scope, and that's what you said from the beginning. Um, if it's just JP Morgan deploying JP Morgan workloads with a JP Morgan owned HSM and managed by Morgan, employees, then yes, all of that, is, you can simplify it all, right?
Well, so it's actually not quite that restrictive. So let me give you some context. We do these build these exercises internally to the firm called architectural katas. I don't know if you've heard of the concept or not, but basically it's an exercise for people who will subsequently go build solutions to sort of pre-train them. And one of the katas is about a multi-party computation inside a T. And in that case, everybody agrees on what the workload does. But nobody controls the code, or everybody agrees on the code. Nobody gets to influence the code. So there could be party A, party B, and then there could be the hoster, right? AWS or whatever, Azure. And then the party A talks to the workload and will have it do certain things, and party B can talk to the workload, make it do certain things. That workload may in fact use different key stores for A-related keys and B-related keys to decrypt A-related data, decrypt B-related data. Also, when that workload goes and acts on its own behalf, it may actually say, well, I'm doing this in the context of A, or I'm doing it in the context of B. And it ought to not be possible for A to get B's keys or B to get A's keys, right? So it's not just like, one code owner and one key store. This kind of allows for that,
Understood.
right?
Yeah.
Because again, depending on so long as the code is assumed to be perfect and properly configured and can be trusted to do certain things,
Of course.
it could in fact be in possession of two sets of credentials.
Yes.
And with those credentials, the same piece of code will or will not get access to different backends to do things.
So you have two verifiers in that case?
You can you can have multiple verifiers because each verifier controls access to its own key store.
And where do you get the reference values for the verifier?
It's part of
For both
configuration.
verifiers.
It's part of a tested configuration.
Okay, but it's the same people who are providing the reference values to the verifiers.
Well, but
Because
if
it comes from this.
if I control my own verifier, I will tell it who to trust.
Okay.
Right? Now you can say, well, I will only believe this workload instance if it trusts me and this other verifier that I also know belongs to the other party. Like we could do that.
Okay.
Yeah. Okay. So, all right. So basically here, the workload owner / control plane. So we'll skip over that for now. Creates the workload identity, basically decides what the workload is going to be called, and then creates the CWK release policy based on workload attestation results. It basically says, this is going to be the identity. I expect the following results to be presented, in which case the key store will release the CWK. Make sense so far?
Yep.
That's the wrapping key. Okay. So then it goes to the key store and says, all right, here's the CWK, and this is the release policy. So only if you see the following, attestation results, are you going to release the CWK? Now, For the threat model, we'll need to make sure that this release policy is properly audited such that you cannot maliciously insert a policy that says, oh, by the way, give this key to my friend Bob, right? And the way you do that is the key store maintains a log of all the policies that it has ever had, and or maybe even has that policy audited before it takes effect. So again, we can talk in the threat model, we can talk about controls we can apply to make sure that this is not abused. Okay, so then the CSK pair is created passing the CWK identifier. And that assures that when and again, I did not make it explicit here, but in a detailed discussion, we can talk about it. So you create and store the CSK pair. You encrypt the private portion of the CSK with the CWK, and then return the CSK and wrap private CSK. And basically, another control that needs to happen here is if I call you again and say, create me a CSK pair, and here is a CWK identifier, but it's a new request, I should probably decline it, right? Because
Yeah,
once a CWK is created, it can only be used to encrypt one CSK,
that's exactly right.
I
right?
mean,
So we need,
replay attack.
it is a form of a replay attack. It's really a key reuse attack. Yeah.
Yeah.
So we need to basically say that, yeah, you can go create a CWK, but the moment you call step 5, you cannot call it, you cannot call it with the same CWK.
So this might be like, sorry, I'm just trying. I'm wrapping my head around things in terms of the threats right now, Mark. And
Yeah.
just on the, and that may be for the threat model, but on the part of the release policy and the verifiers, I think that we need to check for supply chain attacks on that front for both items.
Right. So, good thing, and we can add. You can scroll down, turn suggestion mode on, and under security considerations, in the very bottom of the document, write your thoughts down, and
Yep.
then that way we will not forget. But yes, I agree with you because remember how I said the key release policy needs to be audited,
Yep.
and it could be audited like quite literally in real time. Like maybe this mechanism that goes and does it is my CI/CD pipeline, right? I'm about to push something new into production, so I want as part of it is to set up all the key release material. Well, there is a control that fires on, as part of that key release policy being set.
Yep.
Now, come back to remember how I said the key store is now taking on all sorts of other like I do not know if an off-the-shelf HSM can do this.
I'm certain it can. It cannot, sorry.
Right, but this
There's-
means you need to effectively you need to front the HSM with another service that does that sort of thing.
That's exactly the conclusion we got to, which is that's why you have a network or a network of verifiers of verifiers, and then if you do need an HSM
Yeah,
in the loop, then the HSM is an entity, it participates in the system and is another source of cryptographic material that gets combined, within the TE network. But you need additional business logic that traditional HSMs just do not have. I do know that there are some HSMs. I worked with another startup that said they are able to go and put some new business logic within HSM. So some of them are programmable, but I doubt, I mean, the problem that it would break the certifications and all the other things that you get from an HSM.
yeah.
So
Okay.
for us, for me, because especially this use case is about scaling, for, workload that needs to scale horizontally, very quickly, the idea of having just one verifier sitting there and then relying on HSM, I think doesn't align with the idea of something that needs to be able to scale to very large numbers. So you do end up with verifiers of verifiers, and then HSMs become participants in that system. But you need more than just one verifier, and so you need a TE infrastructure more than just one thing in an HSM
Yeah.
on the side.
Oh boy. Okay. So that's once again, this is where, how do we create sort of targeted documents and help somebody navigate? Because ultimately it comes down to this, it's a Python programmer somewhere JavaScript programmer. They're writing a loan origination app. That's the world I'm in, right? They understand everything about loan origination. They do not understand necessarily the vagaries of HSMs and verifiers and whatnot. And the whatever sidecar or plugin or API they're given to do this needs to be dead stupid simple.
Yeah, I'm very familiar with that.
Right,
Because we automate all that stuff. So we write, React apps that just automatically inherit all the security of the infrastructure. So
right,
it is exactly the right way to do it. But it does require more intelligence and more automation in the decentralized key management piece
right.
of it,
Yeah.
because that's what it comes down to.
Yeah,
It's
they say
all about,
there is no security usability trade-off. They're just lazy engineers. So I'm glad that you're not a lazy engineer.
well, I
Okay.
used to be an engineer, but yes.
All right. So, okay. So continuing. So we generate the CSK pair. We encrypt the CSK with CWK. Basically now the public CSK is returned and it's wrapped with and alongside the wrapped private CSK. So that's just something, in step 8, the control plane holds on to whatever it had received here. Now, the next step is let's create a credential request with the workload identity and the public CSK. And I'm almost thinking that perhaps step, uh, what is it, 9, that I'm hovering over here, and step 5 could be combined. Like, why invoke the, verifier, the key store twice, where it could basically say, just give me all the stuff.
Yeah. So I'm not even clear. I don't remember what that step was about. Uh,
This is so you need to create a CSR. And the
oh, I
only way
see.
to
Yeah,
create a CSR is to sign it with the private CSK, which
yeah.
the left-hand side doesn't have.
Of course, of course. Yeah.
So that's another note to self, is like steps 5 and 9 can be combined. Like I'm probably going to just add a step-by-step instruction manual for each step here to explain, like, what
Right.
needs to be done. This is going to be for next week. I just but walking through this, like, or talking through this, it's like my little therapy session. It helps me figure out what the
Right.
next steps are. Okay.
But you're absolutely correct, and it's again the way that we ended up implementing it, I believe, which is if you trust your verifier anyway, and the verifier is making the decision to pass keys to the workload, and if the workload is not capable of generating its own keys, then it's the verifier that takes on the role of creating the signing key, the wrapping key, that can
Right.
do the certificate, right? The
Yeah.
process the CSR even before it's a real transaction. So that's why
Right.
I'm talking about the bundle that gets delivered to the workload.
Yeah.
All that, you basically just you provision that bundle and then you pass the wrapping key through the TLS session to the workload. The workload will recover that bundle and has all it needs to do this thing. You don't need
Right.
another round trip.
It would be really cool if you wrote a parallel short document with, like, you can start with the mermaid charts. By the way, all the mermaid code is here. So you don't, like, you just literally open mermaid
Yeah,
and copy and paste this text in there, and off you go.
yeah. The
And
yeah.
then you can make the changes, and you can paste the screenshot in here, or in like create a parallel doc. It would be nice to have your swim lane diagram, so at least I can eyeball them side by side. Again, if you have time.
Yeah, I'd rather, there's other things that I need to do, and we can do that outside. The issue here also is the CCC, right? So I'm contributing here, in part of the CCC, but providing deeper technical insights into, the mesh is not, my goal here, right?
Okay.
Until
Well,
until we until we succeed and all that, then yes, of course, all that becomes important, but. Um, so
okay. Well,
anyway,
whenever. It's just would be
yes,
nice if we're going to standardize more than one profile, then
understood, understood.
that would be how it would be good to do. Okay. So now CSR in hand. We have the public portion of the credential key. We have the CSR. By the way, we actually don't even need the public portion here. We just need the CSR, right? Because ultimately we just need the credentials. So that's why I'm inclined to go and like in the for next week, I'll probably just combine these two invocations of the key store
That's right.
to just like give back just what's required. So here, uh, you use the credential request that was returned here to create and sign the credential. Now that's signed with the credential issuer's key, so credential authority. Returns the credential. That's plain text, so no need to wrap. And now the credential and the wrapped CSK given to the workload. So we now know what this looks like. And also fewer round trips means fewer chances for replay, relay, and whatever attacks. So there's just like less stuff to worry about.
Yeah.
And finally, this is stupid simple. You create the CDK pair, that's the key delivery key, the credential delivery key.
Yeah.
And then you generate the evidence, including the public CDK. You request attestation with the evidence. You appraise the evidence, compute attestation results, return attestation results that also include the public CDK. And now your key store, which again is this beautiful thing that can understand attestation results, will validate the attestation results against the CWK release policy, encrypt the CWK with the CDK public, and return it where it can now be decrypted and used.
I mean,
Again,
I really hope that when you go to sleep at night and you think about how much better all of this would be if you collapse these different functions into just one relationship. Your workload should only talk to its verifier. That's the zero trust, the least attack surface, the most,
right.
efficient mechanism, and that's what
Yes.
the CCC should push. The verifier should then take on, a bunch of responsibilities combined, and itself should be verified by a network of verifiers. And so, if that is I'm from the beginning, that's what I've said. We should try to push in that direction because this is the implementation. If you want to have TEs anywhere in your infrastructure, you need to put the verifiers in a TE to begin with because that's where you do the most work. That's where you're going to do the attestation verification results. That's where you have to do some key management functions anyway. And you're probably going to have other, reference values that need to come from other places that they themselves be verified. Guess where those reference values need to come from? They need to come from the verifier of the verifier. And so otherwise it comes from yet another place that you need to trust and that you have not verified. Or if it comes from another place, it needs to be verified. And if it's verified, it needs to be part of the same verification network so that you
Yeah.
have the same, trust model everywhere.
Mano,
Right.
question on that point. So
Yeah.
you're speaking about reducing separation of duties. How do you deal with auditing? Because I mean, it just really means that there's a condensed attack surface, if you will,
Yeah.
right? So I mean, I understand that that's what's being followed right now, but I'm just curious, coming from the supply chain world, where you seek to have transparency logs and actually kind of like a traceable, auditable, uh, I don't know, chain of events, right?
Yeah. Yeah.
So how does that kind of like look like when you only have kind of like that single workload verifier relationship?
You produce because you have all the cryptographic artifacts in the verifier, and because the verifier is itself part of a network of verifiers, and you have to trust the initial verifier anyway in this architecture. The verifiers themselves can be then programmed to, cryptographically chain artifacts that they produce that verify that provide traceability of their own actions. And guess what? They've been verified before they produce the artifact. So we can take that offline because it is essentially what we just described here between the workload and the verifier is a decentralized key management scheme that enables a workload to have its own keys. Guess what? Take that pattern and then repeat it one level up. And now the verifier itself gets a key that comes from its own verifier, the parent verifier, and then it can now use that key to encrypt its own information in a way that is cryptographic, or sign its own, logs and things like that in a way that has been verified. So you basically recurse and you end up with every single actor being, verified and then having its own cryptographic material so that it can generate its own cryptographic logs in a way that it ends up being globally verified. So it's only
All right.
the recursion in the hierarchy of verifiers that you can, solve those problems. But
All right.
happy to take that offline. We would love
Thanks.
to work with JP Morgan on this.
Thank you, man.
Yeah.
Yeah. If you knew our boss, Davis, you'd understand why it takes him a little while to respond to things. I think has a superhuman workload. Okay, so we're kind of done here. I very much encourage you to take a look through the remaining sections that we need to get through. So, we're just about done with the framing and the proposal. As I said, we're doing an implementation in parallel with this, so there'll be some code. Hopefully, I can release it to GitHub when we're done. That basically shows how how it can be done against the KWS and whatnot. And then we need to get to these sections, so fitness for purpose, are there any performance optimizations? If not, we can kill the section. We should talk about credential rotation, absolutely. Like, what's the mechanism for deciding, maybe the key got leaked, now we need to move, or periodically people still have policies that keys need to be rotated.
Yeah, so
and
that's
whatnot.
yet another, but I guess that's a function that HSMs have, right? But
Yeah.
it is yet another function that the key store needs to be able to do, and that you would actually want to automate that too, especially
Right.
for workloads, right, that are ephemeral or that may have short lives, or you want those credentials to be short lived, especially for agentic workloads, as we've seen, with the, the crazy mold. You follow the mold book stuff, right?
Oh, yes, the cluster fuck.
Just yes,
With
exactly.
a big cluster.
But isn't that interesting how this is exactly all the things that you shouldn't do, that are unfolding, in the industry right now. And those are the things that we can fix. So it's fascinating.
Well, yes, and it's such a rat's nest. Okay.
Yeah, sorry.
Uh,
Sorry, didn't want
anyway,
to.
so security considerations. You notice a security bug in anything we just talked about? Put it down here. And again, in the appendices, I'm putting things so you can paste that into Mermaid, so you can re-render the graph anytime you want. Keep suggestion mode on if you have anything you want to add or fix, and then we'll get through these. So I'm going to approve this change for now. That's the biggest one for this week. And then I'm going to go for next week. I'm updating this diagram to remove one round trip to compress them, to talk about the pairing between CSK and CWK. Basically, there's going to be a step-by-step, explanation of everything in here. And then that's what we're going to discuss next week. And then that will be very close to what we actually end up presenting to Whimsy.
Very cool.
Cool. Well, thank you both so much for attending today,
Well done.
and I will see you next week.
Thank
Take
you.
care. Be well.
All
Thank
right,
you.
take care.
Cheers.
Bye-bye.